Okay, today's class we're going to be learning about the topic of how to divide polynomials by polynomials. In the last section we learned how to divide polynomials by monomials, which wasn't all that terribly difficult, sort of like simplifying fractions really. And then this time we're going to learn how to divide polynomials by polynomials. And honestly, this is one of the topics that I found was more difficult when I learned algebra a long time ago. And so I'm going to try to take it step by step and give you a lot of examples so that we make it through. First, before we get into the actual algebra, I want to review just sort of a basic concept, because really it's no different from this. Take a look at this. What is 354? We're going to deal only with numbers for now. Actually, I want to go and write this a little bit lower. 354 divided by 27. Now this has nothing to do with polynomials. This is just something to kind of illustrate the point. How do you do this division? From basic math, what you do is, operationally really, what you do is you see how many times can 27 fit into 3. The answer is 0, so forget about that. Then you move on to the next digit. How many times can 27 fit into 35? And what I mean by that, how many number of times, I mean how many times can it divide into it an even number, I mean a whole number of times. Obviously 27 times 1 is 27, so it'll fit one time into 35. It won't fit 2 times into 35 because that's going to be 50 something. So what we'll do is we'll just put a 1 right here, and we put the 1 over the 5 to signify that this 27 goes into this 35 one time, one whole time. Okay, and the next thing you do is you multiply the 1 times 27. You write the 27 down here. You draw a line. This might start it might start to ring a bell with you guys. And then what I go ahead and do next is I subtract these two. So I'm not going to put the minus sign, but what I'm doing is subtracting 35 minus 27. And when I do that, that's going to be 8. Because if you think about it, 35 minus 27 is 8. After I do that subtraction, I just carry this 4 down like that. Okay. Now I have a new number. How many times does 27 go into 84? And the answer to that is it'll go 3 times, 3 whole times. Okay, and to see that, 3 times 27, if you do that in your calculator or by hand, you'll see 3 times 27 is 81. So it'll go 3 times. Okay, 27 times 3 gives me 81. Now I do the same thing again. I draw a line and I subtract. What's 84 minus 1? That's 3. So I write a 3 down there. Now, there are no more numbers over here to carry down, and 27 doesn't go into 3 at all. I mean, it's bigger than 3, so it can't really go into 3 a whole number of times. So what I do then, and really what I want to just pause and just remind you is what we have done so far, when you really think about this, is what I have shown is that 27 goes into 354 13 times, okay? But when you do that, you still have 3 left over, okay? Meaning 27, if you want to just check it, 13 times 27 is equal to 351. Okay, if it were equal to 354, there would be no remainder down here. But 27 goes into 354 13 times, but even when we do that, I have 3 left over. So how do I write that? The answer, typically the way you write it is 27 divided by 354 is 13, okay, but I've got something left over down here. It's not just 13 by itself. I've got this 3 left over. But typically the way you'll write it is you add on to the end here 3 over the divisor, which is 27. So the answer to this division is 27 goes into 354, 13 and 3/27. Okay. And if you go and you put this in your calculator, if you put 3 divided by 27 in your calculator, you'll get 0.111, and the ones just continue on repeating. So really what you end up with is 27 goes into 354, 13.111, and they just these ones just continue on out. So what we found is 27 doesn't go into 354 a whole number of times. There's some stuff left over at the end. And this stuff ends up being what's behind the decimal point over here, because what it really is you're taking 3, dividing by the divisor here, and that's the fraction that's left over. Okay, now I want you to just, I know some of you guys, this is kind of old hat, but I want you to think about that for a minute, because we're going to start to replace all these numbers with letters, variables, and it's not going to really be any different mathematically what we're doing. It's going to be the same thing. We're going to be taking the divisor, seeing how many times it'll go into the first few terms of the thing, and then we're going to multiply and subtract, and at the end we may end up with a remainder. Sometimes we won't, sometimes we will. So let's take an actual example from algebra. Let's say the problem is this. Let's say it's x plus 2. We're going to divide that into x squared plus 4x plus 4. So I'm going to carry my little thing out here. So I have a polynomial here, and I have a polynomial here, because each thing has more than one term, so they're polynomials. Poly means more than one. Okay, and notice further that I have what's written underneath the thing here, the bar. I have my polynomial written in standard form, so I've got my square term, and then my x to the 1 power of term, and then I've got my number, and then out here I've got it written in standard form. I've got my x to the power of 1, and then my constant term. In other words, when you do these problems, you want it written in this form. You don't want to have the 4 plus x squared plus 4x and then the 2 plus x out here. You want to have the variables first and the highest exponents first. It just makes the math go easier. Now, what do I do next? Okay, the principle is the same. What I want to do is say, how many times does x go into x squared? Just forget about the 2 for now, really. You don't really have to deal with the 2. Look at the leading edge, the first term here, and have an x, and look at the leading edge of the first term here, x and x squared. How many times does x go into x squared? Well, we're going to learn by example. The answer is x. Okay, how do I know that? Okay, how do I know that x goes into x squared x times? Because the next thing I'm going to do is I'm going to multiply this term times this term, just like we did before. X times x, x squared, plus x times 2, which is 2x. Now remember what I'm doing here when I'm multiplying like this, it's basically what I'm doing is x times x plus 2. So I'm distributing the x in here, that gives me x squared, and I'm distributing the x here, and that gives me my 2x. So that's why I wrote down x squared plus 2x over there. I'm going to erase this for the time being. It's not relevant to the problem, but I just want to show what I'm doing here. So what you really need to do when you figure out how many times it goes in is you just need to figure out what do I need to put up here so that when I multiply it, it gives me what I'm looking for. In this case, I put an x up there. X times x gives me x squared, so that's the correct term. Okay. Now, next thing I do, I draw a line, just like I did a minute ago. And just like in the number problem, I start to subtract this minus this. Well, x squared minus x squared is going to give me 0, so I'm not gonna write that down. It's just 0. 4x minus 2x gives me 2x. Okay. And then, just like before, I carry my next number down. I carry my next term down, so I'm going to carry the plus 4. Now I have a new polynomial down here. Now I need to see how many times this goes into this. Again, I'm going to do it the same way as before. How many times does x go into 2x? The answer is, you got to put a plus here because I've got positive numbers, 2. I didn't put an x up here, I just put a 2 here. How do I know this? Because the next step, 2 times this thing, 2 times x gives me 2x, 2 times 2 gives me 4. Remember, the number that you put up here, you just want to pick a number so that when you multiply it by this, you get what you were looking at in the first place. That is the definition of division. I mean, whenever you have 10, and you're dividing 5 into 10, I mean, what are you trying to do when you put this number up here? All you're doing is you're picking a number so that when you take this number, multiply it by 5, you get 10. So I'll put a 2 there. 2 times 5 gives me 10. Same thing, no difference at all. All I'm doing is I pick a number so that when I multiply it, I get the 2x that I was looking for. Okay? Now I draw my line. Again, I subtract this minus this. and that's going to give me a big fat 0 because 2x minus 2x is 0 and 4 minus 4 is 0, so there's nothing left over. Because this is a 0, there is no remainder. So in the number example, we had the fraction with the decimal at the end. Well, there is no remainder here. So the answer to this problem is x plus 2 goes into x squared plus 4x plus 4, and it goes in x plus 2 times. X plus 2 is the answer to that problem. And how could you check that? Well, if you go and take x plus 2 and multiply it by x plus 2 and you do FOIL, you will get exactly what's in the center here. And I will leave that as an exercise for you to go ahead and do. So you can pause the tape right now, take x plus 2, multiply it by x plus 2, and use the FOIL, the first inside, outside, or the first outside, inside, last, basically multiplying the terms together and adding them up. And when you simplify that, you will see that the answer makes sense. Okay, what if we had something like y plus 1 divided by y squared plus 13y plus 12. Again, notice I have everything written in the standard form with the variables first and the highest exponents first. First thing I want to do is see how many times does y go into y squared. That's going to be y times. Okay. Next thing I do is take y times y plus 1. That's going to give me y squared, because y times y is y squared, plus y times 1 is 1. I draw my line. Now I subtract. Y squared minus y squared gives me 0, so I'm not going to write it down. 13y minus 1, I'm sorry, I made a mistake already. So I'm going a little too fast here. This isn't a 1. Y times 1 is y. So y squared minus y squared is 0. 13y minus y gives me 12y. Now I just carry down the next term, plus 12. Now I have something new. I need to figure out how many times y plus 1 goes into 12y plus 12. So what I do is I first say, well, how many times can y go into 12y? The answer is 12. I can do that by, go ahead and multiply the next term. 12 times y is 12y, plus 12 times 1 is 12. Draw my line and subtract, and of course it's the same term. 12 minus 12, 12y minus 12y is 0, and 12 minus 12 is 0, so this is a 0. So there's no remainder. So the answer to this problem, y plus 1 goes into y squared plus 13y plus 12, and it goes y plus 12 times. And again, you can check this, and I'm going to leave it up to you. If you take y plus 1 and multiply it by y plus 12, remember where you have your parentheses like this, and you have your terms in there, and you do the FOIL. First, outside, inside, last. You multiply those terms and simplify them. I promise you, you will end up with what was under the division sign there. All right. Let's go ahead and work another. And remember, with these things, practice makes perfect. So that's why I'm working a ton of problems. That's exactly the way you learn this stuff, is by doing problems. So I've got 10x squared underneath plus 11x plus 3. Okay? And I got 5x plus 3 on the outside. First thing I do, take the first term, see how many times it'll go into the second term. 5x goes into 10x squared. Well, 5 goes into 10 2 times, so I'm going to put a 2 there. But that's not enough because I've got an x and an x squared. I need an x up here. Now the way to check that is 2x times 5x. 2 times 5 is 10. X times x is x squared. So that's why I had to put the x there. So let me go ahead and do that. 2x times 5x is 10x